All right, today we're going to talk about something that can make your applications feel just incredibly fast and responsive. We're diving into streaming and partial responses.
You know the feeling, right? You're just staring at a loading spinner, waiting and waiting for this huge chunk of data to finally pop onto the screen. It is so frustrating, and it makes even the best apps feel clunky and slow.
But what if there was a totally different way to do it? See, instead of the old way, where you wait for one giant response, streaming lets you get little, usable pieces as soon as they're ready. It's kind of like the difference between waiting for a whole book to be printed and bound versus getting each page as it comes hot off the press. You can start reading right away.
And look, this isn't just some neat developer trick. It's really a fundamental shift in how we think about the user experience. So let's break down why this is such a game changer.
The real magic here is how all these benefits just stack on top of each other. First, the perceived performance goes through the roof because your users see something happening instantly. This also gives them a chance for early feedback. They can cancel a search if they see the first few results aren't what they wanted. It all just adds up to a way better experience, and hey, on the back end, it's often more efficient too.
And you've seen this stuff everywhere, even if you didn't realize it. Think about search results that show up as you type, or when you're processing a huge file and the UI doesn't freeze. It's also how those big AI models can show you their thinking step by step. And of course, it's perfect for any kind of live data dashboard.
Okay, so we know why we should do this. But what does streaming actually look like when you're building it? Well, it turns out there are three main patterns for how you can structure that flow of data. First up is probably the most common and straightforward one: chunked results. It's simple. Instead of sending back one giant list with 1,000 items, you just send smaller, complete batches. Send the first 20 results, then the next 20, and on and on.
So what the client actually sees is a stream of distinct chunks. Each one has a few complete documents inside, and then at the very end, it gets a little end signal to know it's all done. It's clean, it's simple, and it gets content on the screen so much faster.
Now our second pattern, progressive enhancement, this one is really clever. The idea is that the server sends a super fast initial answer. It might be incomplete, maybe a little rough around the edges, and then it follows up with more details, refining that answer over time.
For instance, a partial response might land first with just a basic summary. A second later, the final response arrives, and it enhances that first summary with way more data, like entities and keywords. The answer literally gets better right in front of your eyes.
And our third pattern is live updates. This is your absolute go-to for any long-running background job. I'm talking about a big data processing task, a software build, anything that takes more than a couple of seconds. Instead of a vague progress bar, you stream the actual status changes.
So the client just gets the steady stream of discrete updates. The status might change from compiling to testing until it finally gets that success message. It keeps the user totally in the loop and confident that things are actually working.
All right, we've talked about the what and the why. Now let's get into the how. This is our little playbook for building a streaming system that's not just fast, but also solid and resilient.
So to make this happen, you first need to pick your transport. And for most of these use cases, the best tool for the job is Server Sent Events, or just SSE. It's a web standard that's literally designed for servers to push data to clients over a simple HTTP connection.
And the format is incredibly simple, really. You just define an event name, maybe something like result chunk, and then you provide your data, usually as JSON. It's easy to read, and modern browsers handle it beautifully right out of the box.
But building a great system isn't just about sending data. You have to plan for the tricky stuff. Like, what happens when the server is way faster than the client? What if something breaks halfway through the stream? And what if the user just decides to cancel the whole thing?
Let's tackle that first one. Imagine your powerful server is just a fire hose, blasting out data, but the client is, say, a low-powered phone that just can't keep up. The browser tab freezes. This whole problem has a name. It's called back pressure.
And the solution is to implement what's called flow control. You use buffers on the server and you throttle the stream, which basically means you send data at a pace the client can actually handle. It's all about being a responsible sender.
Okay, next problem, the midstream error. You're streaming hundreds of results, everything's going great, and then, bam, the database throws an error. The response is incomplete. Do you just show the user a broken page?
No, you fail gracefully. The best way to handle this is to send a dedicated error event right down the stream. And, this is the crucial part, you can include any partial results that were successful. That way the user doesn't lose everything, and the app might even be able to recover.
One last performance tip. Chunk size is a really big deal. If your chunks are too small, you create a ton of network overhead. If they're too large, you're right back to having high latency. The whole game is about finding that sweet spot that feels super responsive without being too chatty on the network.
Phew! Okay, we've covered a lot of ground here. So to pull this all together and make it really stick, let's just wrap up with a final checklist so you can go out and build these things with confidence.
Here are the 5 essentials. First, choose the right streaming pattern for your specific use case. Then, build in that resilience, handle back pressure, and plan for how you'll manage errors. And don't forget the user. Let them cancel the operation. And finally, tune your performance by finding the right chunk size. If you nail these 5, you're in great shape.
So, the next time you're designing a feature, anything that fetches data or runs a long process, I want you to remember this. The difference between a user who's waiting and a user who's absolutely delighted could be streaming. Your next feature could legitimately feel 10 times faster. So, the real question is it time to stream?